So, the panel is about AI data centers and energy, the topic of this conference and a very hot topic in general today. It seems like an unstoppable force meeting an immovable object. So exponential growth in compute demand meeting real constraints in energy infrastructure. So today we're going to talk about the bottlenecks and what is actually working, what does not work, and what are the opportunities, especially for investors in this space. So first, I'm going to start with a very quick introduction of each of you, which actually you can do yourselves, which is even better. So starting with my longtime friend, Felix Krause of Vireo Ventures.
Thank you so much, Julia. It's a pleasure. I fully understand we stand between you and your lunch. So very short, Felix, one of the founders and managing partners of Vireo Ventures. You actually had the pleasure to listen to 3 of our portfolio companies, and we invest early stage into the all-electrified world. Over to you.
Yeah,
Arne Mortiari.
I'm Arne. I've been doing this sort of clean tech venturing since 2007, so for a long time. First with a firm called ETF Partners, then with something called Kiko Ventures, which I created about 5 years ago. And now I'm working with Octopus Energy to create a late-stage clean tech venture fund with an energy focus. So it's not a CVC, we're raising money, but it's in collaboration with Octopus Energy.
But you wear the wrong color.
Yeah, I'm sorry. There's so much pink in my home by now, but so I stick to the green.
Yeah, and please pay extra attention to Arne today because he is improvising. We actually had a different panelist who is stuck on the airport in New York, so he is willingly stepping in. He agreed this morning.
It's
he did
all
not
on
prepare.
the fly now.
Yeah. So yeah, next, Sudish.
Maybe I could give a bit of insights. What Theo has to fill in from New York. So we are New York-based venture capital. Investing on the intersection of data centers and energy. Last year we said, we come from the energy infrastructure world and commodity space, and we said, with trillions being invested into the space, it's one of the biggest bottleneck AI is facing is its rise to infrastructure and what is the power stack that defines that infrastructure, and that's exactly has been our investment. So we invested 6 investments last year, mostly in California, but also I'm based in Berlin to look at the European startups as well in this space. So very excited to hear more about the space.
And finally, Michael.
Michael Wilshire, 20 years thereabouts at McKinsey, working mainly not in energy actually, but in technology, so semiconductors, hardware, software, all that kind of stuff. Then I was part of a startup, an initial investor in New Energy Finance, which was acquired by Bloomberg, an energy analytics business. And the example I showed you is another energy analytics startup from Sightline Climate, which I help.
Great. So I have some questions for you. First of all, to bring it back to us as VCs. Is the data center build-out actually a VC game, Felix?
That's a very good question. We are seeing quite a lot of startups that want to combine energy and data center rollouts. For us, we have not yet invested, most likely won't invest in a pure data center. But there are very interesting use cases that go along data centers, such as the reuse of heat, because data centers are actually producing, or they need to be cooled down, so they're producing a lot of heat. They can be seen as a flexible asset, managing the loads, managing the electricity that goes in. And so we believe that the whole data center rollout possesses a huge opportunity, but into the data center itself, I doubt it.
Yeah, I agree. So we've seen a lot of different solutions for the grid constraints that data centers bring, like VPPs, microgrids, behind-the-meter optimization. Arne, do you see any of these things actually scaling or things remaining in pilot stage?
Yeah, I mean it's a fascinating space because in theory you could imagine a lot happening, but it's a little bit the same view. I don't see a lot. Let's put it that way, right? So I mean, the whole thing is, I think, it's sort of in my mental image, it's sort of a triangle between infrastructure constraints, the need to be fast, not so much efficient, but fast in just rolling out stuff, getting data centers on the ground, and then sustainability. I think these are the sort of main bits of the puzzle, and the way we're rating it here, for example, versus US is very different. We have very much a sustainability view on the world, of course, but I think most things are driven by speed right now. And yeah, there is behind the meter, a ton of behind the meter happening under that speed heading, which is, let's just buy a whole bunch of gas turbines and run our data center that way. Right? And then there's the corollaries of that. Well, maybe we back them up with a bit of batteries and that sort of thing. And then when you go inside the building, what people often forget, there's a ton happening inside as well. So there are batteries inside, capacitors inside. They're often in the rack even, because there's very, very fast fluctuations you need to buffer out. So that's a very specific type of behind the meter, if you want, and microgrid. Again, efficiency isn't really what it is about. There it's about speed and of response, and it's about just volume of the gadgets, because there's space constraints. So there's a lot going on, but not really the lens that we typically apply as so Eco Summit participants. The sustainability bits, I spoke to someone from Equinor. They're piloting, putting some data centers in the coasts of the offshore wind farms. So there's some stuff like that happening, but it's very, very little. It's basically pilot stage.
Yeah. Yeah, we see that access to power, and especially also grid access, is a major bottleneck for AI data centers. So we hear Elon Musk announcing data centers in space, and we hear a lot of other crazy big ideas to solve this. So Sudheesh, what are you hearing also in the US?
Spot on. We just came back, our team came back from the Data Center Dynamics in New York, and there was only 2 questions right now. It's all about speed and infrastructure. If you don't have speed, you don't have a business case in this game. Not in 2026, not in 2027. There as well, we were looking into, what's the biggest bottleneck? It's access to the grid. So that's more or less what we were looking into. Who could actually find out excess capacities in the grid to find out where to build, those massive ones that looks for AI training, gigawatt scales that is unreal, the edge ones that could have pockets of power. That's the ones that could actually, behind the meter, everybody says, we do not want to do it. Data centers do not want to do it, but it's the only bridge to power strategy that is available until utilities figure it out in this, right? So the question is all of those economics that we hear, behind bring your own generation, bring your own power, bring your own clean energy is also the newest one. They call it BEYOND, which is very interesting acronym. So this questions in between, who could bring that orchestration layer? Battery storage that we invested in California, they could work with, battery storage could do 3 functions. They could absorb the AI training loads. They could orchestrate between the grid and between the on-site power, and also play in the flexibility market. So, and the third, it's slowly coming, is to extracting the value chain, because an 100 megawatt data center has energy cost something between 80 million to 250 million any year, based on how you structure it. So there is a lot of value capture coming in. I'm very curious to see how Europe is evolving in that regard as well.
Yeah. So, Michael, do you also see energy as the main bottleneck for the further development of AI? And where do you think this is going?
Yeah, I do see it as a bottleneck. I'm actually in Texas next week talking to some of these crazy space ventures that are planning to put data centers in space.
Oh, nice.
So we will find out. Although I think that's not really going to affect things over the next 5 years anyway, even if it happens.
It will take longer, yeah.
Yeah. I think, on the energy side of it, I think you mentioned it, but I think if you can bring flexibility to the party, you are more likely to get a grid connection. So if you can do things that actually help the grid operator, they're likely to put you higher up in the queue. So that's one means. I think the other thing to recognize on the semiconductor side is that these chips are expensive, right? And you want to utilize them as much as possible. Yeah, so exactly. If you start to compromise that by providing too much flexibility, you're not going to get a return on your assets. So you want the flexibility to get the connection but then you don't want to be offering too much flexibility that damages your revenues in the future.
Yeah. And so continuing on that topic, Arne, do you think if you compare Europe to the US, are we underestimating this in our approach towards winning the AI race and meeting the energy requirements for this?
Yeah, I mean, unfortunately, I have a relatively negative view. Not only are we behind on the software side, but I think the data center rollout is pretty fundamentally hampered here as well.
Yeah.
Space constraints, these giant data centers is an issue here. Grid connections, we have a much more constrained grid in many ways. We have much more regulatory issues, not just in terms of environmental regulations, but also in terms of just putting things in people's backyards. And so in Europe, I think everything drives towards a more decentralized data center infrastructure. That again flies in the face of LLM type AI, which needs big concentrated compute power. So I don't really know where that leads us to, but I hope there is a next generation AI which can operate a bit more decentralized, and we evolve into a decentralized, orchestrated, data center / energy infrastructure that does things like put things in the wind farms and so on. And that I mean, I think that almost has to be the vision. We're not going to beat America at the giga data center game. I just don't think that's going to happen.
Yeah, I think I share your pessimistic vision there. Actually, last week I was in Iceland, where we are building a lot of data centers. Great work, because they have free energy, renewable, but they're shipping all that data to the US via a big transatlantic cable. So that's not the right way to go, I think. So Felix, can you touch upon how to solve the grid access problem? So can data centers become flexible assets?
I wish I could solve it, but I certainly can't. But I actually believe that what you already said, data centers can be seen ultimately as like a virtual battery, because you can actually shift loads quite easily. I learned that the majority of the compute that is needed in data centers, or data centers are used for at the moment, is non-time critical compute, so primarily AI training data. And if you defer that by just a little bit of time, you ease the stress on the grid, and you can you use a lot less energy if the grid is congested. And I found it really interesting that Google signed an agreement with TSA in Tennessee, the grid operator, and despite the grid already being extremely full, they got the permittance to build a data center there, and they listened to the signals from the market. So to resolve the data center and grid problem here in Germany or in Europe, we always look into the max capacity of something, and we don't agree that the data center might only be using its full max if there's capacity on the grid, and so that you do not need to max out the build of the grid, but instead the grid and the data center or whatever else communicate, so you do not need these massive build-outs, and hence you can be a lot quicker.
Yeah.
But that's a regulatory problem.
Yeah, it's not something you're going to solve.
No, unfortunately not.
I'm sorry.
Is that really true, though? I mean, isn't it all about utilization of the GPUs? So can you actually shift workload around? Don't you need to run these things full power non-stop?
Well, maybe that's a good question for Michael, who just already commented on that a little bit. But can indeed workload efficiencies or efficiencies at the chip level, can they materially offset this power demand?
Yeah, I think, well, the answer to that question is yes. I mean, I think it's not going to stop at 35x or 70x. That's going to continue.
Yeah.
The question is what then happens, and does that just feed back into more compute and smarter models, in which case, you're still up against something of an energy bottleneck. So it sort of solves part of the problem. I'm not sure about moving things. I mean, training maybe, actually, because I think you can probably decentralize training a little bit more. But training is not the bulk of the workloads now. I mean, it's moved. It used to be thought you train these models and then inference is simple, but it's actually the other way around, that more compute is going into inference. And for that, it's partly latency, but also if you've got a billion or whatever, trillion parameter model, I mean, the amount of networking that goes into a data center is huge, and it's all about chip-to-chip communications, because it's not just one chip, it's a whole rack of chips, and it's rack to rack. So I'm not sure you can decentralize that as the models get even.
Oh, I wasn't arguing for decentralized, more for shifting the actual compute to also times when there is more ease on the grid, and just not that the idea is not to completely always shift, but to get the grid connection a lot faster by agreeing with the distribution net provider, operator, that if you know it's going to be super congested, you just pause non-critical compute for some time.
Yes, you could do that. And I think some decentralization, physical decentralization for certain types of application might still work as well.
Great. Okay, so at least some level of solution. So Sudheesh, is AI inference data center demand, can that be a catalyst for energy in Europe?
I think this is sort of what I was looking into in the last months, weeks. This is, Europe sort of positioned ourselves to, we are behind in the AI training game, like we heard from the last panel. The question is whether data sovereignty, data gravity, and the third one, latency, brings in the AI inference close to the user. NVIDIA just announced the AI grid. It's a distributed compute options. It's called AI super factories that could actually be closer to the user. And I think, and I believe, there will be an opportunity for Europe to go into the AI inference game, considering that right now most of the AI training is done in the US. Most of our inference are sent to the US. So could we pull this back in the next 3 to 5 years would be a great opportunity that I think all of those solutions that you mentioned would come closer to us.
Great. Okay, so we're running out of time, I see, so we have time for one final sentence from each of you. So I would like to hear one bold prediction for 2030 on AI data centers and energy, starting with Felix.
Oh, wow. I think we completely underestimate here in Europe the energy demand caused by data centers, and that's going to be a huge problem.
Yeah, huge problem is your sentence. Okay, yeah?
So I think tech companies will become energy companies, and we had this wave of firms like Octopus Energy starting to challenge the existing players, energy players, and I think we will have now a second wave where essentially the energy companies are taking over the tech companies are taking over the energy industry.
Yeah.
I'm curious. Sorry.
Yeah,
I'm curious about what Michael said. What's going to happen with all this bridge to power on-site generation in the next 3 years? How is it going to change the energy markets? Where the prices would go? This would be a very interesting phenomenon to look at. That's what I'm excited about.
Michael?
I'm not sure about Europe, but I think in the US, by 2030, most of this stuff will be built. I think the announcements will continue. Some will fall by the wayside. But I think the pressure is really on to build. And energy is only a relatively small part of the cost of all this computing. So I think that, but I think once you've built them, if you've got a 1 gigawatt data center, you're not going to be able to turn it into a 2 gigawatt data center. So I think from that point on, it's going to be up to the semiconductor providers to innovate and provide the extra computational capacity within that power envelope.
Yeah. Thank you. So we've reached the end of the panel. Thank you all very much for listening, and for the people who are still here in the audience listening, great, thank you. We've learned that AI will not scale where the data is, but really where the power is. That is going to be the bottleneck that needs to be solved. It has a lot of real problems and limitations, but also opportunities in flexibility, in optimization, and new investment models. So we're all going to be following that very closely in the coming years.
Thank you.
Thank you,
Yeah.
panel.
Right?